Okay, the topic I'll be covering today is part of a series, AI across the research stacks. Specifically, I'll be working on search strategy today. We're talking both systematic and narrative review search strategies. Actually, at the beginning of each session within this series, I want to cover kind of what I describe as the funnel. I think we tend to think about research in terms of stages, but I really describe it as sort of a funnel. First and foremost, to figure out from the entire corpus of literature out there on a topic, which ones relate to your research subject, or really all of the literature out there, grade literature and peer-reviewed articles, which is relevant for your research topic. Then a screening process involves figuring out from those search results what should you actually add to your library and review somewhat formally, and then what should make it to the next step in your review. And then a full text article is where you're actually, in many cases, pulling specific empirical findings and data points from those articles and then synthesizing it together. So really is like a funnel first in terms of describing what papers are actually going to come out of your funnel and be relevant for your study, and then which specific elements of those studies should churn out of this funnel, churn out of this engine for your research. I'm going to take a step back quickly and talk in terms of the kind of because the topic at hand is using AI across the research stack. I want to address one thing right up front, and that is we're covering search strategy, but also discovery to an extent. And I bring that up because I think it's very underappreciated how well you can use maybe some of the bigger models like Claude, ChatGPT, Gemini to actually come up with a quick kind of historical account, some background on an area of literature, very specific areas of research. Without a review paper, these in the past might have been tough to find. But if I want to, for example, ask about, in this case, the research question I have is what are the effects of tariffs on international trade? And let's say I really want the background on that specific research question. So the task is tell me about the consensus in the literature on the topic and any nuances. Tell me about how the literature has evolved on the topic. Identify and link a few seminal papers to be aware of. This is actually a wonderful output that you can get from pretty much any of the big models. So let me jump to one right now. And I'm going to be bouncing around a bit. I've got a few different pages open here, but you can see kind of the first one. I mean, it's sort of incredible. I don't think we should take it for granted. Obviously, 5, 10 years ago, this was impossible to imagine where we've got and I've, personally, I've validated the responses behind these. A, because I use it every single day. B, because I know this literature pretty well. And indeed, the consensus is very good. Key findings are very good. Sometimes you have to double check maybe some statistical estimates. Key nuances such as retaliation. That is a great example of something that's covered in all of the protectionism literature. And then, maybe most surprising to a lot of researchers is that the seminal paper identifier in a Claude, for example, is great. I think most people think of this and say, hey, this is where the hallucinations exist. And they're right to an extent. You cannot use these tools to come up with 30 or 40 search results. But if you're looking for seminal papers, say 3 to 5 seminal papers in an area of research, Claude, ChatGPT, Gemini are very, very good at identifying those accurately and providing links as well. And so I would actually say if I'm starting a research project, this is the first thing I'm doing. I want to sort of understand the context of it all before I maybe jump into the latest empirical findings. I want to know the context. So I just want to get off track for a second. That is how I would start, in fact. So, but getting into the actual then search process, finding the appropriate papers for your study, making sure you have a good comprehensive view of papers. Spoiler alert, that's a big problem. And such strategies vary significantly by review type. Probably no surprise to anyone here. Narrative reviews are, as we all know, very judgmental. Authors sort of bounce between some search engines, use some keywords, and then do what I'll just generously call title screening and decide very subjectively which papers to query, full text review. You generally don't have a documented methodology behind your search, or for that matter, your screening. Systematic reviews, as always, are a totally different ballgame. In fact, I knew before doing this research about the rigor of systematic review search strategies. Don't think I could have kind of prepared myself for the amount of, for instance, syntax you need to know, for the differences between databases in terms of how you build search queries, the extent to which they build on each other, etc. So systematic reviews follow a predefined, transparent methodology. Okay, they write it down in detail. And folks doing these types of reviews, and then it's sort of a very clear plan they execute against. I think the first thing I'll actually do is jump into a few of those. Let me quickly cover this. Elements of a formal search strategy, for the most part, two elements: which databases you're going to use, and then what are going to be the actual queries. Pretty straightforward. Systematic reviews, you're using a lot of Medline, Cochrane Central, then Web of Science and Scopus and many others. Queries are, for example, figuring out how to use Boolean operators, which I'll get into in a second. Pico components, population, intervention, outcomes, and I get to see at the moment. But the point is very structured in terms of how you put together queries, extremely comprehensive, as I'll show in a couple examples in a second. A couple other elements I just mentioned, a few important ones. Boolean operators, these always confused me, honestly. Part of it is that some databases accept them and some don't. Google Scholar doesn't handle them very well, for example. So the Boolean operators, the three most important are or, groups all synonyms together to make sure you're basically performing the same search across whatever your keyword and your title is, say, and then all the synonyms associated with it, and is how you link concepts. And so if I want to do a study on, I don't know, let's say I'm looking to collect reviews, systematic reviews actually, and then I want to do a study on trade or something like that. That's where you have trade and systematic review, and then not indicates, of course, what not to select. Here's the example I provided: Fitbit or Garmin or Apple Watch, same categories. You'll notice you don't want Apple, you want Apple Watch. So that's in quotes. And intervention associated with those, but not animal trials. So seems pretty straightforward, but when you get into having, 20 different line items for your search strategy steps, it gets a little complicated. Couple other parameters here: truncation and wildcards. This is just really interesting stuff to handle things like misspellings, plural form. Truncation, you can see the example. I'll just use the example. Exercise stops at the S, asterisk. That covers everything else covered here. Exercises, exercise, exercising. Same thing here is maybe there's a single character wildcard. You want to replace exactly one character, error or errors in this case. I mean, this is really interesting stuff to sort of get trained up on. It's almost like learning the syntax of a software developer or something like that. And just to jump ahead for a second, my instinct is a lot of this knowledge should be automated and should kind of go away, and that won't foundationally affect the research process. So that's kind of the key here. Other parameters, I'll just mention field codes. These vary by database. So again, there's so much, I think, between the truncation wildcards, the understanding of how to actually structure queries, these field codes which vary by database. We've got a couple examples, like you're searching just titles, just abstracts. You sort of bounce between journal name, author. The point is, it's a lot of syntax for, I think, accomplishing some tasks that really should be more automated. And so I think there's a lot of disruption coming to the search strategy space, let's say. Let me walk through a couple examples. I'll just start with a basic one. This is kind of the order of operations I went through. Most systematic reviews, just about all of them, will have a supplementary document within the journal, the publisher site. And so this is one I pulled, a study on lower back pain and intervention methods and whatnot. It's less about the research question at the moment. I just want to show you kind of the rigor, right? It's sort of unbelievable. One thing I didn't understand initially is these are all building on each other. The idea is you get to the end, and that is kind of your perfect search query. It includes all the synonyms you want, all the not, studies you want, the review methods you've exactly selected, etc. Your hope, if you're doing a systematic review, is that you come out at the end of this with, say, a few hundred citations on PubMed, something like that. And I'll go through a specific example there. So let me keep bouncing through examples so you could see a couple others. Here's a really interesting example. I'll walk in depth through this for a second. This is a study on wearable devices, and as you can see here, this one's a little bit simpler. You've got 10 different line items. I've actually gone through a process I know it seems tedious, and this is a little informal and all over the place, but explain these for a second, and you could just get a sense for this, right? Search is the controlled vocabulary that exists in Medline by using that /. So any record that a Medline indexer has tagged with those subjects gets caught in this first one right here. The free text keyword is different. That's titles and abstracts and author keywords, searching those instead. So your first filter is the Medline tags, and then searching in title and abstract, in author, etc. You combine both of those. There's a number of combination line items. Let me move this down here. Intervention context. Here's where you get into things like methodology. What type of model are you looking for? And quickly, I'll mention bringing those two together. Same thing here, going back to studying or pulling the Medline specific tags for meta-analysis. And so we sort of go on and on here, and then we end up with our final line where everything's combined, and the final limitation is English language limit and remove animal studies. Okay, and so once again, the goal here is to get to a place where, hold on one second. Here we go. The goal here is to get to a place where you've built your queries. I've built the 10 here in PubMed. We can see this. You're basically putting in queries, you're adding them, you're searching them, and those get logged. And you're ending up with a very filtered down review of, in this case, 609 results. And for those of you wondering, what do you do with these 609 results? You're generally exporting the full list. I think that's something that's, of course, different about narrative versus systematic. Narrative reviews are kind of one by one. Systematic reviews, you lay out your queries, and then you're exporting the full list and importing it generally into a citation platform or a systematic review platform. In our case, in the case of Mora, this is our library. So I went ahead and clicked import. And then once I got to import, I could actually import those citation files right here. It took a bit, 600 citations. It took probably 4 minutes, and that's a while. But then what you end up with is incredible data. I mean, you take a look. I don't mean to sort of plug this, but you've got all of these citations, which natively certainly did not have things like citation count. Now they've got it in Mora. And so this is at least one of the things you could do with those citation lists. I'll back that out for a second, though. So that is kind of a good illustration of the process. I've actually gone through my own synthesis of 4 different types of search strategies. And I have this quick guide here. I'll share it afterwards. You can use it if you'd like, but covers the top databases, key syntax elements. Actually, the best page is right at the end. Quick reference cheat sheet, Boolean operators, how to specify title versus abstract field, etc. So this could be really, really helpful. So I'll share this afterwards, but that is just a very quick crash course on systematic review search strategies. It's no wonder after viewing that, people get the impression that they can't do systematic reviews without like a year of formal training courses. That is a humongo process. I already mentioned that I've got a guide put together. Great. It's pretty simple stuff, and everyone can take a look through it if they'd like. Now the question, back to the topic of discussion here, is where does AI fit into this formal search strategy preparation execution? And I came into this research not knowing exactly the answer. I think my first answer was effectively the same type of iteration that you can do in writing. So in writing, your first draft should really be your own. And then once you have your first draft laid out, you can then bounce it off of Claude or Gemini to get some ideas for grammar improvements and whatnot. And you can kind of iterate back and forth. Am I missing anything, etc.? And then this would be kind of my textbook answer. But the overarching conclusion I've come to since is, in fact, we should offload a significant chunk of our search strategy, syntax, query development, database selection. So much of this should actually be offloaded and automated via AI. That is my impression based off of some tests that we run that are coming up on the next slide. But I have to tell you, this really strikes me as an area where there should be a lot of automation. And I don't think we cut into any foundational research skills by automating the syntax behind search strategies. I just don't think it's that critical if we're picking and choosing our spots. More tactically, though, a couple bullet points here. Drafting an initial search strategy from your research question, without a doubt. That's kind of what I'm talking about here. You always want to check it, but that's a good starting point. Let me move this up. Translating a completed strategy across databases, great application. We already saw in these examples that each database has their own search strategy. I mean, it's kind of crazy that we wouldn't automate that based on syntax differences. It's like, building brand new software across different programming languages. It just makes no sense. Translating a completed strategy, already did that. Reviewing a draft strategy for missing synonyms, logic errors, or syntax mistakes. That's like the writing application, right? What am I missing? Anything wrong with my reasoning? Any bugs in my code, effectively, etc. And then definitely interpreting an unfamiliar strategy if you find one out there that's interesting, but you don't really get it. Kind of like what I did for this session, very much so. Literally breaking down each line if needed. I did go through a test. I try to go through these types of tests kind of in every session, testing human versus AI search strategies. And I'll just tell you briefly the methodology. It's not perfect, but the methodology I used was to take a specific search strategy for Medline, in this case, associated with the paper on wearable electronic devices, took that search strategy, developed a research objective and set of questions based off of it that included all of these parameters, and then specified the database, and then used Claude, plugged in the research scope, and used Claude to create a new search strategy. And then what I did is, per usual, this is kind of my methodology I've been running with. I anonymized the results. So I took the actual search strategy here. And then I used search strategy number 2, which was the Claude-generated search strategy. I also mentioned focus less on format in case there's a copy paste issue, more on substance, keywords, Boolean operators, etc. And for what it's worth, here are the results. Let's start with Claude, and what I'll say with Claude is search strategy number 2, which is the Claude system, is substantially stronger for a number of different reasons, among them how it's kind of structured, and inclusion of scoping and rapid reviews, therefore, having a broader scope, etc. And then, more indicative of anything, set aside the Claude results. Claude was used to generate the search strategy. Gemini has the same exact thing. Search strategy number 2 is significantly better. So, look, I typically, when we do, say, search results, and I test different search engines, I'm in a good position to evaluate them from a human perspective as well. In those cases, my opinions nearly always line up with the opinions of these models. However, in this case, I'm less qualified to evaluate the structure and syntax of a search strategy. I will die on the hill that there's good information contained in this consistent result across both search engines. And so that's just really interesting to me. And, my takeaway is this: let's automate search strategy. It's very rare. I could be wrong about it. I'm open to different ideas, but my thought is let's automate this thing. This is software development. This is kind of understanding some syntax elements, Boolean operators. All of this should not be such a barrier to entry for new researchers wanting to do systematic reviews. So let's automate the thing and call it a day. These are not research skills that are foundational to coming up with new conclusions. All we're talking about is sifting through databases of papers. I don't think this is, I think this is a task that can be very much automated. So that's my view. And then look, I happen to feel like one of the big questions we can answer here is, or sort of task is, how does it relate? Systematic reviews, narrative reviews, how do the two relate in this context? The reality is the pendulum needs to fall in the middle. It never does, but systematic reviews, to come up with those search strategies, you're talking about days of planning. It is effectively a coding project. You need to know the Boolean operators. You need to know the syntax of different databases. It is such an unnecessary barrier to entry now that we've got these new technologies available. By contrast, narrative reviews are you jot down maybe keywords randomly. You don't even write them, but you just kind of type them in sporadically. You got a couple filters, and then you just kind of select papers, title screening, you might generously say. And so we need the pendulum to fall in the middle, okay? This is where 90 whatever percent of reviews exist. They're narrative reviews, i.e., at least they're not systematic reviews. We need something formal. We need a methodology, but it can't be systematic review search strategy. That's just crazy. It's not accessible for most researchers. So it needs to fall in the middle. And look, my view is that the real power of AI and search strategy, therefore, is bringing structure and transparency to narrative review searching that didn't exist before. Okay, this is kind of a common theme across all of my sessions, presentations, research topics. Okay, let's, on a spectrum, get narrative reviews maybe looking just this much more like systematic reviews so that we can actually get some comfort and we can get a handle on the completeness, the comprehensiveness of an author's search strategy, of their, literature search. And so, very specifically, a practical guide. Start with your research question. and just ask AI to brainstorm queries and synonyms and related terms. No rocket science there. Make sure you have good software in place for deduplication on the go. Most of the software used to search in narrative review context, the search engines, don't have the same type of functionality in terms of downloading hundreds of citations and then screening them. But at least make sure you're not, spending time on redundant papers. In a site like Google Scholar, if you don't have a plugin, an extension, or an integration software, that's a tough thing to do. Ask for database recommendations via AI if needed, and then build your library, then check again with AI to ensure no major items are missing. Let me speak about a couple personal things here in terms of my experiences. One is that it is extremely difficult in some fields to understand the architecture of the and kind of naming schemes associated with an area of research. And what I mean is you could have a topic you're researching and you've got maybe a few papers that align with a certain title. Effects of tariffs on international trade is the example I use often. However, little do you know, there is a massive amount of literature under a related set of titles, maybe titles that have the word protectionism in them, like the economic effects of protectionism. And for one reason or another, you might not capture those in your initial searches. I mean, this is a great way to make sure that you're not missing any high volume areas of literature that are super relevant for your topic. And so these are great ways. That's one great way to use AI in this context. Another would be this. Look, when we're building libraries on the go very quickly for our users, we are often taking a, say grant project title and description, plugging it into a Claude, asking for 5 keyword combination queries, plugging those into, say, a Google Scholar, saving 50 papers down to our library, and then lastly, plugging that library back into Claude and asking it to call out irrelevant papers, or on the flip side, significant papers were missing, areas of literature were missing. So there are so many ways you can iterate, so many ways you can conduct much better search, much more comprehensive search, using AI to help you figure out what do I plug into my search engine. That strikes me as a non-critical area, yet again, to automate. Certainly the benefits outweigh the costs if it means we're getting more comprehensive coverage over an area of research. And last thing I'll cover is Mora, always, kind of talking about the Mora context of all this. I would say let's get technical about one specific point. Mora is a place to bring together tons of papers from many sources with automated deduping. So whether you're bringing in citations, PDFs, or search results, all the deduping will happen in Mora. And then what's more, I'll mention one other thing. If you are specifically using Google Scholar, which a lot of narrative review researchers do, or if you're using Semantic Scholar, which is our other search engine, you'll notice this. If I'm on Google Scholar and I need to type in a query, exchange rate, effects of exchange rates on international trade, the example I'm always using. Okay, let's say I add these two to my library, and then just for kicks, because I haven't had much time to come up with synonyms and whatnot, let's say I typed in this query and the same paper came up as it should. I've already added it. And so I don't have to go through the process of adding it again. Certainly if you're working literally in Google Scholar, you don't have to go through the process of jumping into the site, downloading the PDF again, or anything similar. And as we can see, these both show up right here with full DOIs, citation counts, author names, etc. So that would be the main way to use Mora to help with automating and improving your search strategy. Really technical, really mechanical, but a very important sort of behind the scenes set of functionality for this purpose. So really appreciate the time. Hope everyone's having a great week. Thanks.